Now that we have taken a look at the definition of radian measure, let's look at an application of the definition. The definition of radian measure, just as a reminder, is if you have a central angle theta subtended by an arc of length s in a circle of radius r, then that is how we define radian measure. So theta is the arc length divided by the radius. And you can see in the definition that I've given a screen capture of, it's the definition of 1 radian. But if you want the definition in general, it is the length of the arc that subtends the angle divided by the radius, where they have equivalent units. On the picture before you, you have a circle which has a radius of a equals 5 and a central angle of 120 degrees. It's important to note that in the definition of radian measure, the relationship between the arc length and the radius and the angle in radians is intrinsic to the angle being in radians. So we need to have 120 degrees converted to radians. And a simple way to do this is to remember one conversion fact, that for every 180 degrees, the value in radians is the number pi. Okay, this is one way to do it. So without simplification, we could say 120 degrees is 100 times pi divided by 180 radians. Another way you could approach it is from the table I noted in a previous video, that 120 degrees is twice 60 degrees, and at some point very soon it's going to be important that you recognize 60 degrees as pi over 3 radians. Okay, so you can notice that 120 pi over 180 radians would indeed reduce to 2 pi over 3 radians. Okay, now to find the length of the arc, which is part A, with the radius 5, if we solve for s in the definition of radian measure, we get r times theta, which is 5 times theta in radians, or 5 times the value 2 pi over 3. Would also be totally fine to write 120 pi over 180. The area of the circular sector relies upon the formula for the area of a circular sector, which is derived in a different video, which is 1/2 the square of the radius of the sector times the angle in radians. So the area is 1/2 the square of 5 times the angle measure in radians. And again, with the appearance of the calc pad, there's no real need to overly simplify, which is kind of nice.